So hi everyone, this is Eric Appleton again. I just want to remind our presenters, if you could mute yourself on your phone and then unmute when we, at your moment to come in, that would, I think, probably be better to keep the background noise to a minimum. I'm going to keep you unmuted through free conference call so you can mute and unmute yourself. Everyone else, you'll be muted for this call, but please participate through the chat. And we're going to start in just a couple minutes. All right. Good afternoon, everyone. This is Eric Appleton. I wanted to welcome you all to our first math TASC webinar. We're very excited about doing this. It's been a long time coming. I'm excited to see the group of people we have here today. I see a lot of old friends on the list, and I'm also excited to see a lot of new people who are joining us. It's really exciting. We welcome this opportunity to share information and connect some very knowledgeable parties with some fantastic teachers around the state. So this is really exciting. So if you haven't gotten a chance to yet, please introduce yourself, name, program, region, through the chat, and hopefully everyone's finding that speech bubble on the top of the screen. And one thing you're looking to get out of today's webinar, please share questions, comments, ideas at any point. We'll be keeping track of those and addressing as many as we can during the course of the webinar. So again, my name is Eric Appleton. I'll be hosting the webinar along with my colleague Mark Trushkowsky, who I'll introduce in a few minutes. I want to start by just going through a few notes on the webinar today. If you don't have paper and pencil, by the way, you might want to grab some. We're going to do a little bit of math. You can use a calculator if you like. That's fine as well. So some notes on today's webinar. All the participants have been muted. We do want your participation though, so please write your ideas in the chat box, as I said. And if you have any technical problems, please send a private chat message to me. You might notice when you open up the chat window that you can choose a particular recipient. And so you can send a message to me and we'll try and sort it out. And the webinar today will be recorded and available at collectedny.org, which if you're not using already is a place where we collect a lot of information about teaching. It's a good place to visit. And we'll be sharing the webinar recording there. So our goals today, this webinar is part of a larger project, which is the New York State Adult Education Teacher Leader Project. We've been meeting for a few years now with a group of amazing teachers statewide who have then been going to do professional development across the state, helping teachers think about how to prepare students for the task and for college and for careers. And so this is part of that work. And so there's a lot of teacher leaders. There are a lot of teacher leaders on the call today, and I know that other folks have been invited as well, and that's really fantastic. Our goal here is to share as much information as possible so we can all do good work. So our first webinar was last July in science, and that recording is available on collectednewyork.org as well. And that was prompted by the release of the TASC item specifications, which also inform today's webinar on high emphasis and high utility content on the TASC Math Exam. And our main goals today are we hope that teachers will leave with a better understanding of how to narrow the scope and how to choose high utility, high emphasis math content. There is so much math that we could teach, and there is a broad sweep of math that is covered on the TASC exam, and so we're trying to help teachers figure out how to get the most bang for their buck, and help our students make quality progress, build strong foundation, and pass the task and move on to college and other opportunities. Other goals that we have today are that we'd like teachers to leave with an understanding of the kinds of questions that students may be asked on the task. So we'll be looking at some practice sample questions. And finally, we want to connect teachers to the available teaching materials that we know about, and maybe hear from you about other teaching materials you know about in order to teach this content well. So I'd like to introduce today's presenters. Again, my name is Eric Appleton. I'm a math and science professional developer at CUNY's Adult Literacy and HSE Program. Before I came to CUNY, I worked in an adult education program for formerly incarcerated people, and I've taught all subjects in adult basic ed and high school equivalency. I've been working in adult ed since 1999. One thing I thought we might do today is to give our presenters a chance to check their mic levels and also give you all a chance to recognize their voice. I've heard that radio producers sometimes ask their interviewees what they had for breakfast, so I'm going to ask that of our presenters. Excuse me. And in case you were wondering, I had toast with peanut butter and a cup of tea this morning. So Deedra Arvin joins us from DRC CTB. She is a test development director and oversees the development of assessment programs, including the TABE test and the TASC high school equivalency exam. Prior to her work in assessment, she taught high school chemistry, physics, and physical science. She has worked in the field of assessment since 2004. Deedra, thank you so much for being here. We really appreciate it. Could you say hello and maybe tell us what you had for breakfast this morning?
Hi, this is Deedra. I had coffee and ham, egg, and cheese on a pretzel bun for breakfast this morning.
Cool. I'm jealous. That sounds exciting. Our second guest is Tim Jones. He joins us from the New York State Education Department, where he is an associate in instructional services. For the last 3 years, he has served as the science and math content specialist for NYSED's high school equivalency unit. Tim is certified to teach physics, general science, and mathematics. He has taught high school math and science in both regular education and special education settings, including teaching high school equivalency preparation in a correctional facility. Tim, thank you for being here. What did you have for breakfast?
Hi, Eric. I had coffee and what passes for a bagel here in Albany.
You know, I tried to make bagels with a young friend of mine the other day, and it was a disaster, so be lucky for what you got. Finally, I'd like to introduce my colleague, Mark Trushkowsky, who is a math professional developer for CUNY's Adult Literacy and HSE Program. Before coming to CUNY Central, Mark taught beginning reading and high school equivalency level math. He has taught all subjects in adult basic education and high school equivalency and has been working in the field since 2001. Mark will be in discussion with Tim and Deedra about the TASC math content and the implications for our teaching. Hi, Mark. Good morning, or afternoon. So, breakfast?
Good afternoon, everybody. Do you mean first breakfast or second breakfast?
First one.
First breakfast, I had yogurt, berries, and these cinnamon heart cereal that my daughter liked.
Cool. All right, so we'll go ahead and get started. So our agenda for this afternoon is we're going to start with a launch, an activity that it's called Notice Wonder that we use as an instructional routine in a lot of our math and science lesson plans. Then Tim and Mark will talk about functions on the task, exploring different math questions that can be asked from the same real-life question. Deedra will then give us an overview of the TASC math test blueprint and the TASC item specifications for math. And then Mark will ask Tim and Deedra questions about some of the changes to the TASC reference sheet, which was just recently updated. So we're going to start with some specific problems dealing with functions and then zoom out to consider what is covered and not covered on the math subtest in general. Each of the presentations will end with a Q&A, but please post your questions at any time. We'll be looking for questions to share with presenters during a Q&A section at the end. And we'll definitely be looking for some feedback at the end of the webinar. So we're going to start with a Notice Wonder launch. The basic structure is very simple. It's 2 questions. What do you notice and what do you wonder? The goal of this is to activate background knowledge, find out what students know, and generate questions. We'll talk a little bit more about it afterwards, but first we're going to try one out together. So take a second to read this and look it over before I ask you any questions. Okay, so now in the chat function, consider this question. What do you notice? What stands out to you? What's interesting to you? What do you see? So whenever you're ready, start sharing stuff in the chat, and we'll give you a few minutes to respond to this question before we move on. So some of the things that I'm seeing as commentary here, the distances are in miles, but they're out of order, so it's a little harder to process. Maybe there's a ratio of dollar to miles, cost for each trip. Right, so there's a lot of things being noticed here. The data is random, not ordered by miles or cost. It's not a simpler multiplier for the cost. So that's an interesting thing to notice. So Kelly, maybe, so if you said it's not a simpler multiplier for the cost, what are you seeing that makes you say that? So what do you notice that makes you say that? It doesn't seem like there's a direct ratio. So Sherry says that. So that's another, I guess I might have the same question. What do you see here that makes you say there's no direct ratio? And Leroy noticed there's no question here other than what do you notice? Okay, so my next question is, what do you wonder? What questions occur to you? So go ahead and start writing questions in the chat box. You can continue to write things that you notice. That's fine as well. The farther someone lives away, the more it costs. $1.50 increase for each mile increase. Is that true? A linear function? 1 mile is $4.50, but 3 miles is not 3 times more than that. Okay. So Maria, you said, what do you want to know? Well, one thing I would ask is, what do you want to know? Is there anything that intrigues you, something that you want to know about what's going on here? Is there a flat rate? What is the cost of a 5-mile trip? What is the cost if I went 0 miles? Is there a service charge? Is there a starting amount? Okay. What other questions could we ask? So now I guess my next question is, what questions could we ask? I'm sorry, what math questions could you ask your students maybe, based on what we've seen so far? So Peter shared a function. I would ask, what is it that you see that makes you say that? How much would a 15-mile ride cost? Which person got the best bang for their buck? That's a cool question. Okay, so please feel free to continue adding questions or things you notice. We're going to keep looking at this same situation here, but we're going to look at it in different ways. So one thing I want to talk about while we're noticing and wondering here is I want to talk a little bit about why we use this instructional routine. Another way to, I guess, to ask that question would be to say, why would you introduce a math problem without a question? What Leroy noticed earlier. Some of the reasons why we start math problems without a question sometimes, or with a notice and wonder, is that everyone starts at the same place. Anyone can notice things, anyone can come up with questions, even in a multi-level group. So it gives everyone a way to enter into the problem. We also notice that it slows students down. So instead of jumping right to the question and trying to answer it, they will look a little more carefully about what's going on here, noticing patterns in the numbers, thinking about the situation. What would happen if we didn't go anywhere at all, 0 miles? That's sort of an odd question, but it takes into consideration what the actual situation is here. And sometimes students just look at the numbers and don't really think carefully about what the context is. We've also noticed that everyone notices different things. We all benefit from each other's observations and knowledge, and we can see that even in the chat right here, that there are many different ideas that collectively will shed a lot of light on this situation. And the notice wonder helps us assess what our students know. So that you can kind of get a sense of the kinds of questions, the things that people notice, what it is they already understand about, in this case, functions. And it generates interest and it promotes students asking their own questions, which we think is very valuable in its own right, in terms of motivating and generating just curiosity and interest in the subject matter. And so I'm going to turn this over to Tim and Mark, who are going to look at some task-style function problems and discuss the content and the types of the problems. Just a reminder that we'll have a Q&A to close the webinar, so please post your questions as they occur to you. Okay.
Thanks, Eric. Good afternoon, everybody. Good afternoon, Tim.
Hi, Mark.
Like Eric said, we're going to be looking at a series of questions dealing with this same taxi service situation that you've all been thinking about. I should mention that this situation comes from Unit 2 of the CUNY HSE Math Curriculum Framework, which, if you are unfamiliar with, is a set of lessons and activities that we developed for teaching functions, which is available for free download and which we'll give a little bit more details about at the end. So we're going to be looking at 5 different problems, all dealing with the same situation. I developed them based on analysis of the last 2 readiness exams. So that's forms 4 and 5, which are the ones that align to the current form of the TASC, the GHI forms. So for each one, I'm basically going to ask Tim to speak a little bit about the content that's being assessed and how important that content is for students. And then I'm going to ask him to say a few words about the form of the question and the way that the test designers are trying to assess that understanding on the part of students. So take a look at there. Please take note the situation's been filled out a little bit. There's one more additional sentence. Same 4 friends, same distance and cost. When they arrived at the restaurant, they compared their cab fare and tried to figure out a rule that the taxi company used to calculate cost. So we're going to take a look at the questions, which is, which linear function models the relationship between the number of miles driven M and the cost of the cab ride C? And here are the answer choices. Everyone take a minute and please write your answer in the chat, which you can just say the letter. All right, I'm seeing some general consensus, with the answer being, in fact, C. So Tim, can you first of all let me thank you, because this is a really great thing that I feel like Eric said this is one of the goals, but to be able to bring you and Deedra together to the field to just talk to people directly, both of you as experts of what's on the task. I cannot thank you enough. And so I'd like you to speak about what's the specific math content here. What do students need to understand about functions to answer this?
Well, functions certainly an important part of the TASC exam now. I think we're going to look at the blueprint a little more detailed, but it's a little over a quarter of the test is considered functions. And there are a variety of ways functions are assessed on the test. Many of our students are highly likely to not be very familiar with functions, and even some of our teachers may be somewhat intimidated by the idea of teaching functions. But it's really, most of these function problems are in some sort of context like this question is, and it really is just about pairs of data that can be presented this way in a table or in a variety of ways. Could be in a graph, or they might give the rule for the function. And what is the rule? The rule is usually some sort of mathematical equation that gives us what we do to an input value to get an output out. And so here, this is one very typical kind of question we might see on the task. I'm going to give you a plug right away for the curriculum framework. The HSE curriculum framework that Mark mentioned is just a terrific set of scaffolded lessons that works very well with people that have very little exposure to functions, may not even have strong backgrounds in math in general, and you can take students that don't have that strong background and really bring them up to the level of the task function questions. I'm very impressed with that curriculum framework. I recommend that personally. So this question, notice that they were using just C equals some value of M, and that's one way we may see functions on this test, is using just variables rather than formal function notation. So
Tim, first of all, your check is in the mail for the plug for the framework. But seriously,
I'll settle for half the profits for this nonprofit venture.
For a free document, you can have all the profits. But there are a couple of things that I wanted to kind of go back to or ask a little follow-up on. One thing you said, and this was something that we tried to do throughout the framework, but you said that one thing that students are going to need to do is look at a real-life situation in context. And how that relates to a function. And so I wanted to ask, so I designed that based on the idea of what I saw in the framework, not in the framework, but in the readiness assessments, which I would say about half of the questions were in a context. And a lot of the ones that were dealt with this situation, how to look at a real-life situation and how do you express that as a function, or taking a function and making a statement about a real-life situation. Is that, it seemed like it was about half the readiness test. Is that something that we should expect on the task, or like when we're preparing our students, is that something that we need to keep in mind?
I think that the readiness test is very indicative of what the actual task test is like. What you see with the readiness test is really a half-length task test. The questions are drawn from the same item pools and written to the same specifications. So then these examples, I think, are very indicative. Now, as far as context goes, you're right. I'd say at least 50%. The intent of the task is to really not just test calculation or strict algebraic manipulation, but really look at some problem-solving skills and interpretation of information that's in a written format or maybe a graph, and be able to understand the concept behind it, pick out the pertinent information, and then solve the problem. So in particular, the functions, I think, is probably more than half of the functions questions would be in context, because that area really lends itself to this kind of word problem.
Thank you. So we're now going to look at the same situation and the same problem almost, same answer. The only real difference here is what's highlighted in red. And so just to make it clear, the only difference between these two things is what's highlighted in red. And Tim, you had made mention that the previous question was one form of function notation that students might see and should be comfortable with. Can you talk a little bit about this form?
Absolutely. This is an important point to make for all math teachers for the task. That we do see about roughly half of the functions questions are written the way the first example was, just using straight variables, and then maybe the other half would have this formal function notation where you read it as C of m. It's the function value for any input value of m. And the C of m, you hopefully are familiar. If it was graphed, the C of m would be the y-axis and the m would be the x-axis on a standard Cartesian coordinate graph. I think it's really important that we bring students this introduction to formal function notation if it's not something that they have studied, particularly older students. If someone's been out of school for 10 years or more, there's a good chance that they were not required to ever study formal function notation. And frankly, they're probably going to think that C of 6 or C of m means C times that value. Normally when you put a variable in front of parentheses, that's very basic. The way we see two examples here actually on the right side, you see C of 6 equals 1.5 times 6. Well, 1.5 times 6 is just by putting the number next to the parentheses. Well, that's what people generally would think probably you're supposed to do, multiply C times 6. But obviously, function notation means the value in the parentheses for the function value is the value we're going to insert into the function as an input.
Thank you. So we're going to keep going. So we have here our familiar situation. Nothing has changed. And so on the readiness test, I saw a lot of questions like the ones we just looked at, where students need to understand how to use a function to represent a situation. Another common question stem that I saw was this. which statement is true about the cab fare. And my question is, Tim, that feels, I mean, obviously the answer to this question is not going to be a number. And so what's the goal of a question like this? What are they trying to assess about a student's understanding?
Well, this is a nice way to assess some careful reading in the context of the question. It's just another form for a question like this. It really is just the point I would make to my students would be sure you read all the alternatives very carefully, and also read the question stem very carefully. Which statement is true about the cab fare? Generally, most of the vast majority of task questions are framed in the positive like that, which is true, but there may be a question or two which is not true. So very important to do close reading on these questions.
So I'm gonna put the statements up in a second. But one thing that you just said that I wanted to just follow up on. So when I asked what they're trying to assess here, the first thing you said was close reading, and so the idea being that they're assessing students' abilities to read a situation and understand it on the math section. Just to clarify, that's what you meant?
Absolutely. Literacy goes across all the subject areas, and it's certainly a big part of mathematical problem solving, and like we mentioned, roughly half the questions are in a context where close reading is going to be level 1 skill we're looking for.
Excellent. So thank you for that, and I'm now going to put up, this is the full problem, and so for the participants, if you could, again, in our chat box, put your answer, what you think is the answer to this question, which of those 4 statements is true about the cab fare.
I'm seeing a lot of right answers.
So I am confused because I am seeing a lot of D's, but when I look at this, the ride costs $4.50 for each mile, and I see Denise rode 1 mile, and it cost her $4.50. So I'm confused. It's not A? Tim, talk to me.
Well, it's certainly, if we only looked at one data point, at the value for Denise going 1 mile, that would be a reasonable answer. But it's a very important point to make that we need to look at more than one data point anytime we try to figure out a function, at whatever level that might be. So here you really have to compare what happens as we go from 1 mile to 3, or what I tend to look at is what happened as I went from 6 miles to 8 miles. That's a kind of an easy set of numbers to analyze here. Notice the cost went up from $12 for 6 miles to $15 for 8 miles. So an example like this is great way to get a class involved. This is another way. The way they're written out as verbal rules, these are functions, even though they're not written as equations. This is telling what to do with an input to get an output. So just another way we might see a function.
Right, and I would add to that, be able to say what an input and output is in the context, because if you look at choices B and D, you have to understand what the starting amount is and what the rate of change is in that specific content, in that specific situation. One thing that I think, I'm glad that you said what you said about the first one, because when I looked at this, and again, I based these answers kind of on what I saw. Like the readiness test had a lot of very compelling answers, and a couple of people in the chat have mentioned the word each in choice C, where it says for each 10 miles driven, the cab ride costs $18. And a bunch of people wrote in big capital letters each, because if you take out the word each, that sentence is true, but it's really just that word each. And I guess what I'm asking, or what I'm wondering is, when I look at this, it's not only assessing, it seems to not only be assessing what students need to answer the correct answer, but it's assessing what understanding they need to ignore the compelling but not quite right answers.
Absolutely. Yeah, in assessment we call those alternatives that distractors, and we like to have distractors that are plausible. So it really is a matter of understanding the wording here and being really knowledgeable about how to interpret mathematical phrasing. Each is an important word, and that's a lesson I always tell anybody I've ever worked with in mathematics is you have to read very carefully. In mathematics, one word difference makes all the difference to the question.
And I'd just like to add to that, Tim, when you talk about we want plausible distractors, we want them to be easily identified as incorrect by someone who possesses the skill that we're trying to measure. So we want it to be clearly incorrect to someone who has the skill, but reasonable for someone who doesn't have the skill. So someone who doesn't understand functions and how the word each is used in mathematics, these are still reasonable answers to someone who doesn't have those skills.
Well
Thank
said.
You. So, Tim, and I guess Deedra as well, I didn't use any vocabulary here. I didn't use rate of change. I didn't use slope. I didn't use starting amount. I didn't use y-intercept, though obviously those concepts are in play here. Can you talk a little bit about specific to functions, just maybe even just among those four, since this, to me, is really asking students to understand about rate of change and starting amount, what vocabulary of those words, those vocabulary words for functions, which ones are important for students to have a firm understanding of?
Well, I think the rate of change is certainly an important idea, and the idea that on a graph that represents the slope is important. As far as how to calculate slope, that is somewhat of a challenging idea that is fair game for this test, but may be something that you would want to save until you were further along with your classes and your classes had a little more experience with algebra and so forth. A lot of these questions can be answered without that formal language of slope. You certainly should be familiar with the idea that these can be graphed, though, that the inputs can be the x-coordinate, the outputs are generally the y-coordinate, and the features of the graph are something that's also kind of a high-emphasis topic. There might be minimums or maximums, so there might be an initial value or certain intervals in a graph or a function where the function increases versus decreases, and features of a graph like that are definitely a high-emphasis topic.
So one last point one last question that I'd like to ask. And we're on a webinar, and so we can't ask participants, but it seems like people came up with their answers. Many people came up with them, I'm assuming, before they did any calculations, and it's certainly possible to answer this question, I think, doing no calculations. When I looked at the readiness test, you've already said that the readiness test is a pretty strong indicator of the task. I found, I would say, half of the questions didn't actually require calculations, which isn't to say that students can't do some calculations to feel comfortable here, maybe try out a couple of the distances and see if they get the cost that matches these statements. But can you talk a little bit about that? Because that seemed like I was very surprised by that over half the questions didn't require calculations.
I think that's a fair observation. This test is really supposed to be of the commencement level high school mathematics. So the focus of the test isn't so much on arithmetic calculation. There are a lot of calculator neutral questions where there really is virtually no calculation involved. And then of the half or so that have calculation involved, not that many of them do you really have a high level of arithmetic involved. So it really is more about understanding and problem solving, but that doesn't mean people should just completely forego learning their multiplication tables or anything else. They still would want to understand how negative numbers are combined, for example, but I wouldn't want someone to have kind of an old-fashioned mastery learning attitude that we can't go on and study functions or study algebra at all until we've really mastered all the pre-algebra skills. There's a lot of ground to cover that it's not necessary to be an expert on long division or on subtracting fractions with unlike denominators to still have a good chance to answer most of the questions on this test. So don't be hooked on the idea that someone needs to have all the tools in their tool bag before they start studying the algebra or the functions or the geometry even. It's not necessary.
Okay, thank you. So we're going to look at another problem. This will be our fourth version of the situation. Same situation, but the stimulus is a little bit different. So I just want to point out that here the stimulus now includes the function equation. So it has the same table, same opener, but then it gives the function equation. So here's the question. And again, I'd like everybody to please take a couple minutes and work through this. The question is, halfway through the meal, the group's friend Isabel arrives. Isabel, who also used the same taxi service, paid $22.50 for the ride. What distance did she travel? So if you guys could put your answer in the chat, that would be great. Thank you. Tim, as people are working on it, a question came in through the chat, which I think is relevant here. The question was, how many of the questions are multiple choice and how many are open? So this, on the test, obviously this would need to be either a grid question or a constructed response. So can you say what numbers, or Tim or Deidre?
Well, most of the questions are multiple select or not multiple select, multiple choice questions. Or selected response is what we call those. There's some questions, I think it's about 10 or 11, Deidre, that are gridded response questions that are basically like fill in the blanks. You can grid a number into the answer sheet, so there's not alternatives. You have to just come up with an answer like this question would be. Then there are one, maybe two-part question that's the constructed response item on each test. Those are basically short answer questions that you have an answer blank on the answer document to fill in. It looks like you have room to write an essay, but there really are short answer questions that may require just a number or a short verbal response.
So would a question like this, obviously we could just put a grid and this would be a gridded question. Could this also serve for a constructed response, this specific kind of question, where like the answers that are coming in are 13 or 13 miles, all of them? Right. Could the answer be as short as that on a constructed response?
It could be, yes.
Okay.
And certainly a gridded response, this would be typical of a gridded response question.
So for a constructed response question, those are worth 2 points in mathematics. So we wouldn't just ask, what distance did she travel? We might say, what distance did she travel? Show or explain your answer.
Right.
And they would have to do something in addition to that. So we wouldn't just ask, what distance did she travel for a constructed response, because we do want to make that worth 2 points.
Right.
Excellent.
And some
That's
of those
super.
constructed responses are two-part questions, right? So there may be a second related question on the same item.
Right. So it could be asking for a show your work or explain your answer, or it could be asking, what distance did she travel, and then asking another question on top of it.
Right. I like this question. To me, this shows the connection between functions and algebra, too. I mean, probably most of the math teachers out there are going to realize that we just substitute the 2250 for the c in the function, and then you have a two-step equation to solve. But that's not the only way someone could arrive at the answer. They could continue the table. There's a variety of problem-solving methods that someone could do without having to use algebra here. So that's one of the nice things about these kinds of questions.
Yeah, I would agree. I'm glad that you said that, because there's certainly this is a strong math problem. I think someone needs to know a lot about functions, have some really strong fundamentals. But the fact that it's not, there's many ways to approach it. I think it's from the perspective of as for myself as a teacher, that I'm excited about that, because I think I would definitely have students, like you said, that continue the table. I would have students who might do guess and check and say, well, if 8 miles cost 15 and I want 22.50, so I'm going to try a little bit more and keep. And I think that's great, and I think that it gives students a fighting chance when there's more than one way to solve it. Because if there's only one way and you don't know it, there's nothing you can do. But if there are other ways, I think that and you have a sense of problem solving as something, well, I'm going to try different things. I think. So I like that. I'm pleased that you identified that as something that would be on the test, because I think that I don't know, that gives me a little bit of hope.
Yeah, I think this is an excellent teaching example, is the way I think about questions like this, because it does lend itself to such a variety of problem-solving approaches and ways to analyze the problem. Right, and all of which show an understanding of functions, I would argue. So let's look at the last one. And so this one is a little bit different. So it's 4 friends use the same taxi service to meet at a restaurant for dinner. The graph to the right shows the distance traveled in miles and the cost of each friend's ride. But this is a little bit different. So I'd like everybody to take a minute to get reacclimated. And Tim, I'm going to ask you to do some noticing for us. First thing, before you kind of weigh in as an expert, just how is this different from the way the situation has been presented in the earlier versions? What do you notice? Well, obviously it's presented as a graph this time. The data points are the same, but that would only be noticeable if you go and actually look at the points and see how much 15 miles cost and all that. But the graph also makes it nice for asking questions about values in between the given data points, and even the starting value is obvious here. And this opens up a great avenue for class discussion, and this set of items together, I think, really presents to us the different ways that we can model functions and kind of pulls together the meaning of it all.
I'm going to follow up on that in a minute, but I'd actually like to look at the actual questions that we created for this. So the first one, with that situation presented as it is how much would it cost to ride for 10 miles? So Tim, can you talk us through how you might solve that, or a couple of ways if you can think of more than one?
Well, first thing I'd probably point out to my, I don't know, whoever I'd be talking to, I guess. But I'd look at the axes on the graph. I'd notice that miles were the horizontal axis and cost is represented on the vertical axis. So you can simply trace over to where 10 miles is and then go up and see where that graph intercepts with the 10-mile mark. And it looks like it's about 18, and that's not a surprise. I think we already had calculated that somewhere along this lesson, that 10 miles would be $18. So again, just a variety of questions that you can ask when you're presented with a graph like this. And one point I think is a good place to make is graph questions like this aren't just an important part of the math test, but you can see similar questions with graphs, certainly in the science test and maybe even on the social studies test, where identifying information, being able to pull it off and interpret what it means, or what some of the features of the graph, like the starting place or even the rate of change, the slope might mean in the context of the question. So these are kind of general skills that are, part of mathematics, but they're also part of other academic subjects and part of the other subtests on the TASC.
Right. Thank you. So we're one last question. So this is the same question that the first one that we looked at. If C is the cost of a ride, just asking for the function equation that matches the situation. Can you talk a little bit about, in terms of what students are being assessed on, if there's anything to add, because you've shared a lot, but how asking the same question but with this stimulus is different for students, how it's assessing something different than the the table was.
Well, you could talk about slope-intercept form of an equation if you had the right group of students here. The correct answer is clearly in slope-intercept form, even though it's not an XY graph. It translates just into a CM here. I don't know. You stumped me, Mark.
Well, I guess one thing I was wondering, as I was thinking of these questions, I thought it would only fair if I tried to think of my own answers. But I think, and you touched upon this before, but it comes down to the situation, the fact that this is rooted in a real life situation, and so you have a graph. So what is the cost? Like if you know what the starting amount is, what that concept means, and you look at the graph and you can identify that when there's no miles driven, it's cost $3, right? And you can see that that's where the line crosses, whereas A and B, if you understand about graphs and you're familiar and you've seen different graphs, you would know that that would go through the origin because there's no starting amount. Just things like that, like just the visual aspect of it. Like you said, there's different ways of looking at this, even though it's the same data points. So I was just curious. I was just wondering if that was from the perspective of a test question creator, if you would it be the same things that they would be looking for? Or would there be is specific to the stimulus, but maybe it's just that it's the core concepts of functions are what is being assessed in either situation?
Well, I think it's the core concepts are certainly are there for all these, but really, in this case, it really is a familiarity with just how algebraic expressions are used to model verbal situations, and that is very much a high emphasis topic, whether we're talking about functions or algebra for this TASC blueprint. So that's probably the big takeaway for this question to me is be sure to try and get your students familiar with the concept of what a variable is, of how a variable represents some quantity that can change over time, and then how these mathematical sentences can be used to model a situation. So just a basic understanding of how functions and equations are used to model.
So my last question is kind of a summary question looking back, because we looked at 5 questions that obviously have a lot of content overlap, but they're pretty different in the way that they're being asked. And from what you said, they're all fair game on the test. And I just kind of wanted to, I'm just processing that and trying to process that, in terms of something that you said, that functions are this large part of the test, and if we need to help our students do it, but there's all this other stuff, and kind of that was one of our main goals for bringing you and Deedra to this opportunity to kind of speak to the field is, I feel like that's a pressure that everybody is feeling, like having to. There's this idea that we want to cover everything, but it seems like you have to spend some time on functions if we're really going to be preparing students for all of these different kinds of ways of asking these questions. And so any advice or any final thoughts on kind of just the overall, these 5 questions as a whole?
Well, I would say that I think that these 5 questions really show you the very much the types of questions about functions that are generally asked on the TASC test. And it really is about having a general familiarity with just the basics of algebra, the basics of graphing, and modeling with equations. So this is a great set. This is the kind of stuff that we are looking for our students to learn.
So with that, I want to thank you, Tim. For the participants who have been writing really great questions, could you please continue writing your questions in the chat? We're going to have a Q&A at the end, and then questions that we don't get to, we're going to try to, when we post this webinar, get you some responses to them then. But thank you. I want to thank you, Tim. And we're going to turn to Deedra. So thank you, and Deedra, and welcome again. Thank you so much for taking time to talk to us. And so, like Eric said in the beginning, the thing that we're going to start off this section are, there are tools out there to understand what's on this test. And so the first two that we're going to look at right now are the task blueprint and the item specifications. And so thank you. We're just going to jump right in.
Okay.
Oh, you're okay. Technology. I have fear of technology, and this is working out so well. So, Deedra, can you, just to kind of get us situated, can you, to start, just explain the way this chart works? I think it's familiar to some people, but it might not be familiar to everyone.
Yes. So this is the TASC Math Blueprint. And in the first column, you see the domain or the reporting category. So the information that you will find out about each of your test takers that have completed a task test in math. So you'll know how they did in algebra, geometry, functions, number and quantity, and statistics and probability. And then each of those reporting categories is made up of subdomains or core ideas. And so in algebra, we have arithmetic with polynomials and rational expressions as one of those subdomains. And then this blueprint shows the percentage of the test for each of those subdomains and also the percentage of the test for the domain. And if you're familiar with the blueprint from the D, E, and F forms, you can see that the blueprint for G, H, and I is the same at this reporting category level as it was for D, E, and F. That doesn't mean that the test is the same as it was in D, E, and F.
Deedra, may I interrupt? So just to clarify, you mean the fact that algebra is 26%, geometry is 23%, functions 26%, number and quantity 13%, and statistics and probability 12%, that has not changed?
That has not changed.
Okay, thank you.
What did change as we went from the D, E, and F forms to the G, H, and I forms, we looked at that content and the specific standards that are enclosed in each of those subdomains and domains. And we considered, is this really what examinees need to know, understand, and be able to do in order to demonstrate high school equivalency? And in some cases, there was content that was included in the D, E, and F forms that we felt, based on feedback from our partners like New York, and also talking to some of our experts in the content and in adult education, that perhaps some of those specific skills or standards were not really necessary to demonstrate high school equivalency. So those standards were eliminated from the blueprint as we went into the G, H, and I forms. If you would like to see the specific standards that are included within each domain and subdomain of the task test for G, H, and I, those are posted as the detailed blueprints on tasktest.com.
Right. And I'm sorry, I should have clarified that what we're looking at is not the blueprint, it's just the chart in the beginning of the blueprint. It's not the blueprint itself.
Yeah, this is the overall blueprint, and then there's a very detailed blueprint that gets down to the specific standards.
So while we're looking, first thing that I just want to say is those changes that you guys made, as you were asking, are these standards that were on some of the earlier versions, were they still were they needed or appropriate to demonstrate high school equivalency? One, I think that's something that a lot of people have been, teachers have been trying to figure out how to keep up with the changes to the test. And so just for the participants, we're going to be looking, the way that we're going to dive a little deeper into that question is by looking at the changes in the reference sheet. So hold on to your hats for that. But while we're looking at this, Deedra, I had a couple of questions. Mostly I wanted to touch back and ask a little bit of a follow-up to points that Tim made, I think. And one, when we were looking at that final question for the functions, we were looking at the graph, and Tim made the point that the science and the social studies exams also have that's a place where students are assessed on their ability to both understand graphs, but also what those graphs are saying about a particular situation or context. So when I'm looking at this blueprint, it's statistics and probability 12%. Are those kinds of questions that appear on the science and social studies exams counted in that 12%, or is that a further are those more statistics, more graphing questions that appear on those other sections?
That's a great question. So this 12% is just the items that are on the math subtest. So in addition to this 12% of the math blueprint, then additional questions that are in the science and social studies require those same skills. So just because this says that 12% of the blueprint is statistics and probability does not mean that we should adjust our curriculum to limit statistics and probability to 12% of our curriculum, because some of those skills are being assessed elsewhere within the science test or within the social studies test when some of those skills are required in science or social studies.
So let me ask you a question, because you were a former science teacher, correct?
Yes.
So I'm thinking about how teachers might respond to what you just said, and I guess the question I have is how do I want to say this? How important is it to teach those graphing skills in a science in a science context? Excuse me. Just, I guess as a recommendation, not like as. Does it make sense to, when you're looking at graphs, to be looking at just graphs, or looking at graphs in a context of some scientific context or some social studies context?
The way that I like to consider the teaching of science is we're not teaching students or examinees, we're not teaching them specific science facts. We're teaching them how to think and act like scientists. So we want them to be able to read like scientists. We want them to be able to do math like scientists. We want them to be able to interact with their world like a scientist would. So in science, I need to be able to read graphs that would apply in science. So I need to learn about that within those contexts of being in science. Because if I learn the skill of reading a graph in math, and then it's just expected that I can apply that in science when necessary, it's not going to click with me, because I'm not going to realize and understand how that information transfers unless that transfer is demonstrated to me as a part of my instruction.
Thank you. That was very helpful. The last thing that I wanted to ask you about this slide, so when I look at this, and this was something that Tim said, but algebra and functions is 52% of the test. And so, I know a lot of teachers have that, struggle with that idea, and it was, functions were very rarely even on the GED, so it's everybody's taking, we're having to figure out how to adjust and how to adapt, and that's kind of a big idea, and one common thread is to kind of start at the basics and then build your way up. But what I've heard from a lot of teachers who are frustrated by that is by the time they get to the algebra and function sections of their classes, it's towards the end, like class is almost over. And so Tim said something that, that's not necessarily the only option, to wait until the very end. And so I was just, again, as a teacher, if you had any thoughts, if you agreed with that or disagreed or had some advice around that issue.
Well, I think it's really important to understand that these reporting categories are based on the college and career readiness standards for adult education, and those came from, and I know this is a bad word in some places, but the Common Core State Standard. And because of that, we know that we're not talking about algebra as just what you would learn in Algebra 1. There are a lot of things that you're learning from the very beginning of your education in math that are the building blocks that let you build up to algebra or build up to functions that you might be doing in a high school class. So some of those understandings, that foundation really needs to be built and made solid so that our examinees can learn those more complex skills later. So I think it's really important with all of our examinees that we are working toward building to that understanding, and we don't wait until we think they're ready for the very complex material to get started with that.
Okay, thank you for that.
Can I add one thing here, Mark?
Sure.
Before we move to the
Please.
slide. Deedra just mentioned that these are all from the College and Career Readiness Standards for adults. And one point that I've seen in the chat box is if you look at the geometry standards, or the subdomains here, the fourth geometry one, similarity, right triangles, and trigonometry. Well, trigonometry we're going to see on the reference table has been removed. And the word trigonometry is here in the blueprint because it's the name of the subdomain from the actual original Common Core standards. But trigonometry is not on the test anymore. It's not part of the adult ed standards, so it's not on the test. But the right triangles and the similarity are very important emphases. Particularly the Pythagorean theorem is a high emphasis topic for right triangles. But as far as sine and cosine and tangent, that was on a previous edition of the exam, but no longer. So I think you really want to look at these subdomains with a bit of a educated eye here to realize that not every topic is going to be emphasized straight by the percentages here. They're interrelated, and some of these areas, like for example another one, linear, quadratic versus exponential models. Linear models are more common in the real world and probably a more important focus. Understanding that you get parabolas from quadratic equations and exponential models shoot off higher and higher, faster and faster. Those kind of understandings that are more general are good. But we're not looking for a high-level analysis of exponential models or anything like that.
Thank you. Thank you both for that. I think that's one of our goals here is to use your expertise to help people make sense of these resources. So that was great. I'm being told that Eric has a question for us, so I'm gonna turn it over to him for a second. And what do you got for us?
Hi everyone. We let you know that we're keeping track of questions that come through the chat, and we'll have a Q&A at the end. But I wanted to insert one question now because it's just in response to something that was just said. And so Deedra, this is for you. I'm just reading something out of the chat here. This is from Solange in New York. She's responding to what you were saying about wanting our students to think like scientists. And said this requires a lot of depth in teaching. We find that this is often at odds with the TASC, which covers many more topics in science than we can cover in a semester or even more than one semester. If we want to teach thematically and deeply, do you have any advice regarding this? So I was wondering if you have any thoughts about that.
I think it's really important to plan for being able to get the most bang for your buck. So as you're looking at the curriculum that you have planned and you're looking at the standards that are in those detailed task blueprints that are going to be covered, for what material is going to be covered, you want to look at the connections between materials and where can you talk about one item and be able to just make a connection for your students that's explicit so that they make sure that cements in their brain for them. But you want to look across the standards, not just within a subdomain, but across all of the domains and reporting categories, and where can you relate information so that you can teach more deeply while still allowing students to have access to the information that will allow them to succeed on the task.
Thank you for that. So the blueprint is just one document that has come out to kind of help do that, what you're talking about, choose and understand how to get the most bang for your buck. But another document is the assessment standards, and I'm just putting this on to let people know once we post this, you'll have this screen, but I have it queued up to a specific place that I'm going to take us to. But this is from the TASC Math Item Specifications. And so Deidre's going to give us a little bit of a tutorial on how to read it. And our goal with this is to understand how, as teachers, we might be able to make sense and use this this document, which wasn't created for teachers, but there may be some things that teachers can do with it. So Deedra, can you help me get situated here? What are these different pieces? What am I looking at here?
Okay, so for each of the standards that is included in the TASC test, there is one page or sometimes multiple pages depending on how much information we have. So there's a table for each of those standards in the item specifications. And that table starts with the domain or the reporting category. So for this example, it's algebra. And then the subdomain is also listed, and you can see that the code is going to include that A code for algebra, which tells me the domain, but it's going to add SSE, which is seeing structure and expressions, which is our subdomain. And then when we move on down to the standard, then we see that repeated again. So it's A for algebra, SSE for seeing structure and expressions, and then 1, because this is the first standard within that subdomain. And then we have the text of the standard, interpret expressions that represent a quantity in terms of its context. The next row in the table is the emphasis level. And this particular standard has an emphasis level of high. And what that means, high, medium, or low, reflects the emphasis within the pool of items that is used to develop the test forms for GH&I. So a standard that is listed as high is going to have more items in the pool, and therefore more items on each form that are aligned to this particular standard than a standard with an emphasis level of medium. And a standard with an emphasis level of medium is going to have more items in the pool than a standard with an emphasis level of low. Then we move on to the evidence statements. And the evidence statements identify what it is that the student might be expected to do in order to demonstrate understanding of that particular standard. So what can they do? What's the evidence we have that they have mastered the skill in that standard? Then the next, and my screen just, there we go. Then the next we have the assessment limits or the content constraints. And that tells us anything that we would use to limit the types of questions that we include on the TASC test. So for example, in this particular standard, we have the assessment limit that context is required. So that means we're not going to ask a question to interpret expressions that represent a quantity in terms of its context. Well, it's right there in the standard that is in terms of context, which means every question aligned to that standard is going to include some sort of a context. The DOK, that stands for depth of knowledge, and it's a way of measuring the cognitive complexity of the items. And what this says here is it's a DOK 1 or 2. So the majority of the items aligned to this standard are going to be measuring a DOK 1, which is recall or being able to use a formula, or they're going to be DOK 2, which is more of a comprehension where they're using information that they're given in a slightly unique situation. The next row is the sample item STEM or STEMs. In assessment, we refer to the STEM as the part of the question that leads up to the answer choices. So in a multiple choice item, you're going to see, the information that the student is given and the question that is asked, and those are a part of the STEM. So this example here, we provide some information about a mixture containing C liters of cleaning solution. And then we have two different sample STEMs that could be asked. A, what does X plus Y represent? And B, what does XM plus YN represent? So those are two different questions, and they could have answer options, which would make them a multiple choice question, or maybe they wouldn't, and this would be something that could be in a constructed response type of a question. Below the sample item STEM, many of the standards within the item specifications also have a sample item, which includes the STEM and answer options. For this example, it is a multiple choice question, so you also see that the correct response is indicated in parentheses at the end of that response for answer choice B.
Thank you. Wow. So there's a lot of information here that's being given, and this is just one standard for one subdomain. So I guess one question I have, just in terms of that question, that idea that you raised of teachers getting bang for their buck. If you were planning your semester or your class, which of these, where would you look on these documents as you're looking through this? Which of these categories would you use?
I would start with the evidence statements. Because that tells me what it is that I'm asking my students to do. And if that evidence statement is somehow not clear to me, then I would look down into the sample item stems or the sample items so I could get some ideas of the way that these understandings might be represented in a test question.
Excellent. That is very helpful. So I think we want to make sure that there's time for the Q&A, but we do have one last section, to talk like you both mentioned, but Deidre, you talked about several times about that shift, the change, the way the test is kind of adapting to redefining what high school equivalency students need to demonstrate. So we're going to look at a couple of the changes from the TASC reference sheet, just to see what there is to be learned. The first thing we're going to look at is actually not a change, but it is something. So this is from the current math reference sheet, and so I just wanted to look at what's on the reference sheet with the information from the item specification. So the specific standard that I wanted to look at for just a minute was to use volume formulas for cylinders, pyramids, cones, and spheres to solve problems. So one thing that a couple of teachers have been asking about, there's no area of formulas on the reference sheet. There's just volume formulas. Does that mean that there's no area on the test, or that it's assumed that students will know those beforehand?
It is assumed that the students would know how to calculate area. For example, in the volume formula for a pyramid, they're supposed to use B, the area of the base. And it is assumed, based on the college and career readiness standards for adult education at those earlier levels, that prior to the high school equivalency level, where they are using those formulas. So they're introduced at an earlier grade level or an earlier, adult education level. So we expect by the time they get to the high school equivalency assessments that they know how to calculate the area of a base without having the formula.
Okay, thank you.
I'd add to that it's absolutely vital. There's definitely going to be questions where the prerequisite knowledge is that for a standard rectangle, the area is length times width. And another important formula that everyone should memorize is the volume formula for a rectangular prism or a square-cornered box. It's just the volume is length times width times height. So those are vital, important questions, vital formulas to memorize. And the questions may or may not, they may use algebra. You may multiply a couple of algebraic expressions or 3 algebraic expressions to find a volume in terms of an expression rather than a numeric answer.
Well, I'm glad
foundational is very important.
I'm glad that you said that, because the last thing I wanted to look at for the standard were the sample item stems that came. There were 2 that are available, and they seem different to me. And so, Deidre, maybe if you wanted to take a crack at just what do you see when you look at those 2 questions, or what do teachers need to know when they're looking at those 2 questions?
Okay, so when we ask students to be able to use volume formulas to solve problems, we are looking not just for them to do calculations. Solving problems is also demonstrating your understanding about how these formulas work. So in that second stem, how is the volume of a cone affected by doubling the height? Then you would look at the volume formula for a cone, and you could just look at the formula and say, well, if I double the height, then that's going to double the volume of the cone, because that's how they're related in this formula. Or I could say, okay, if my height is 1, then my volume of my cone is pi r squared divided by 3, but if my height is 2, so I double it, then it's going to be 2 pi r squared over 3, so that doubles it. So I can use it. I can use numbers and do a calculation to be able to answer that question, or I can use just my conceptual understanding of that formula. And both of those are acceptable ways to approach a question like this. We are looking for examinees to not just be able to plug and chug into a calculation, but to also demonstrate their understanding of the concepts behind these formulas.
Thank you.
I'd add a little to that. Particularly the second question here, affected by doubling the height, that we might very well see equations in the science test where you're asked a similar idea. If the quantity is squared by doubling it, it would be 4 times as great, for example. So understanding what happened when you change the values of variables and what you see in the formula is important. I'd also throw in that these formulas are on the reference sheet, and they are high emphasis. So they're a good place for kind of the introduction to algebra, where you teach people how to plug and chug and evaluate expressions. They also have some fractions thrown in, some exponents thrown in. So I would really make sure that you familiarize your students with these 4 formulas, with those shapes in general. A question may not tell you that it's a cylinder, but you may have to model, say, a log or something that would be modeled by a cylinder. So we're looking for general understanding across the entire concept, really. So these formulas are important, but don't think that you need to go into greater depth than what we've just talked about with them.
Thank you both. So we're just going to look at a couple of more. These are changes to the reference table. So at an earlier reference table, the coordinate geometry section looked like this. It had those 3 formulas, and now it is just this. Is there anything either of you would like to share about that change?
Well, I think in this case, it's safe to say that the midpoint formula and the distance formula were removed from the reference sheet, and the expectation should be that you will not need these formulas now. There's at least one example of a formula that's been removed that you will still need to know. That's the density formula. I think I'm probably jumping the gun on that. But basically, the goal here for this, we reset the blueprint for the GHI here to meet the adult learning standards, and they really are designed to meet the minimum qualifications for a high school diploma. And for almost every state in the country now, that's an Algebra 1 course. And so the Common Core standards, of course, cover geometry and trigonometry and more advanced mathematics. So we've really cut this blueprint back. I think it's a very reasonable decision that has been done here by DRC, and New York has supported it to remove some of the standards that are from those optional math courses and rein in the content to more what's required to graduate.
So the reference sheet includes the formulas that examinees would need to answer questions based on the standards that are included in the blueprint. So because standards that were tied to the midpoint formula or the distance formula are no longer included in the test, then those formulas are no longer included on the reference sheet.
Thank you. So I guess that answers my next question about this. But so the trigonometric identities, this was from an earlier reference sheet, and this is now what's left of that. This is a point that's been made, but I think can't be overstated, since I think there is a lot of confusion around this idea of trigonometry. But so just to clarify, you're both saying that trigonometry is no longer something that students will be assessed on?
That is correct. We're not going to need any of the sine, cosine, tangent. None of those equations will be used, so none of these formulas need to be included on the reference sheet.
Okay.
The density formula, that is one difference. And the reason that density was removed from the reference sheet is that density is used in multiple different ways. So we talk about population density, not just the density of a substance being its mass divided by volume. So we felt that in some ways having density equals mass divided by volume might be misleading as to what we mean by the assessment of density within the standards, which focuses, I think, more on things like population density. So that has been removed from the reference sheet, but density is still a part of the TASC test.
Right, so that's an example like the area formulas of things that students need to know and can't rely on having on this sheet.
And the density formula is also going to be something to be valuable for the science exam.
Man, Tim, you love the science test.
Oh, I love my math and science.
So I do want to, I'm going to end this session. I'm going to wrap it up because I do want to have some time. I know there's some great questions that have been coming in, but I just wanted to look at one more. You guys, I think you guys have said, you have made the point, but it was just very stark for me. That's it. I'm not making a mistake. There's no technical difficulties. There's just nothing on that side. So thank you both. I'm going to turn it over to first there's our contact information, but I'm going to turn it over to Eric, who has some questions for the field from the field. He's been actively working away on the chat, and he is going to be sharing some of the things. But if I don't get a chance to come back later to thank all of the participants, thank you all for taking some time out from your day and being active, and also thank you for the work that you do, and thank you to Tim and Deedra again for taking this time. Okay, Eric, over to you.
Thanks, Mark. Hi, everyone, again. I'm going to start, Tim and Deedra, I'm going to start with a couple questions that we collected before in advance of the webinar today, and I'm going to get to, well, hopefully we'll get to as many questions as possible. We might not get to them all because we want to end on time, but I just want to say that we're making a commitment to answer these questions as best we can, and we'll share our contact information. Mark and I will share our contact information at the end here, and do what we can to answer any of these questions that we're not able to right now. So one of the questions I guess that I wanted to ask is about the calculator, because unless I missed it, I don't think we've really talked about it much. And so one of the questions that came in is about the TI-30XS and how many features it has. So for either of you, what are the things that students really need to understand about the calculator?
Well, I think one of the biggest points is really that there aren't going to be that many questions where you're really going to need the calculator. Of course, half the test is calculators available and the other half it isn't, but it really are not a lot of long arithmetic type questions involved. Some important features, I'd say, it wouldn't hurt that you do have the calculator, again, back to science, the science test, the calculator is available for the whole science test. And even it could be fair game on the math or the science, but scientific notation would be one area that you might use the calculator to introduce the topic and have your students be familiar with both answers that are expressed in scientific notation by the calculator or just how to input input the numbers in that format. The square roots are certainly something to be familiar with, square roots, cube roots, and I did see, I'll throw it in there, fractional exponents are still part of the blueprint. They are limited to the 1/2 power and the 1/3 power. The 1/2 power, it should be known, is the same as a square root. 1/3 power is the same as a cube root. Beyond that, there's a heck of a lot of buttons here that you're never going to have to teach them how to use for the TASC test.
But those, I've noticed myself when I first picked up this calculator that just doing powers and square roots, cube roots, it wasn't immediately obvious to me on how to do that. So students will probably need a little bit of practice with that, right, if we want them to be able to use this calculator on the exam, right?
Certainly want to make sure they understand the second button, that gets you the secondary functions of each of the function buttons.
Well, thank you. Let's see. I'm going to bounce around a little bit. this is a question for either of you. What exactly is the distinction between functions and algebra as it's seen on this test? There seems to be a lot of overlap. How should teachers think about that?
Well, there is a lot of overlap. It's in some ways it's kind of artificial to separate them, but generally the functions, one important idea of a function is that every time you have an input, there should be a single output, and that's kind of the definition of a function. So, and then this idea that functions can be modeled so many different ways, as a table of values, as a arithmetic style equation, as a graph, even as just a word description of what you do with the input to arrive at the output. But beyond that, the questions that are considered algebra for the task probably would be more what you think of as classic algebra questions with variables. There's probably more of these algebra questions that are a little bit that are presented without a context. You may have to add a couple of algebraic expressions by combining like terms. You may have to, use the laws of exponents to simplify an expression, for example, things like that. So there's certainly, it's very hard to pull apart what's really functions and what's really algebra, and they're so closely related here. But the function stuff, the examples we looked at in the beginning are very, very typical of the variety of functions questions that you'll see.
Okay, thank you, Tim. Deedra, here's a question for you. What math exactly do my students need to know for the TASC science exam? Newton's laws of motion, scientific notation, bacteria, exponential growth, percent change. Is there any direction? Because it doesn't seem like that isn't on the math blueprint. I don't think. I was wondering, how do teachers know what science math to teach?
I would look at the science detailed blueprints that are also available on tasktest.com. But all of those things that you listed, and Tim can jump right in and respond to this as well, all of those things that you listed, the exponential growth and the, using Newton's laws and those sorts of equations, those are all pretty good places to start with the math.
Yeah, I agree. That was a good list of ideas that are important for the science test. I think just being able to plug in, basically what I always call plug and chug into a formula. A science question may give you a formula and some values, and you have to just plug in the values and evaluate the expression from there. Rate of change, average, isn't a very important idea. You won't see a standard in the blueprint for average because it is one of the, it goes down in elementary school now where we teach students to find a mean or an average. But that's certainly something that could be on the science or the math test. And, it wouldn't just be a question necessarily find the mean, but it would involve some interpretation of the stimulus. You might have to look at a table of values or interpret a graph and be able to get the data from some context like that to then calculate an average. So that's I think we've covered most of the math I could think of that would be foundational to the science test.
Is it right
areas that you mentioned in the question were really important, by the way.
Is it right to say, my take was that it seems like it's more likely that students will see a formula, that they're given a formula, let's say distance, rate, and time or something, and then asked to use it with some given 2 out of the 3 variables or something like that. Maybe that's a more simple equation than is what usually is used. But is that more likely to happen on the science test than on the math test?
I don't know if it's more likely, but it is likely to happen on the science test, absolutely. And actually, I want to say that formula that you just gave, distance equals rate times time, is another one of these foundational mathematical ideas that we should try to make sure that all of our students understand that. It's not going to be given on the formula sheet, but the idea that that's how you that would have played into our taxi cab example, for example, distance equals rate times time.
So, it looks like we've run out of time, unfortunately, and I really want to apologize for not being able to get to everyone's questions. There are a lot of really good questions, and again, I want to make the commitment to collect these questions and do our best to answer them, and then distribute answers to this group. We have your email addresses from your registration, so we will be in contact, and you should have our emails as well, Mark and I. So please be in contact. I want to give Deedra and Tim a chance. If any final thoughts that you'd like to, something that we missed that we didn't get a chance to talk about, or something you'd like to talk about next time we do this, if we're able to. Maybe Deedra, would you start? Any final thoughts?
I do see one question in the chat that asks about the questions being in a real-world context, and I did want to just address that very quickly, that yes, we're looking at high school equivalency, so what do examinees need in the real world? And you're not going to get approached in a parking lot by someone with a microphone asking you to have memorized an equation and be able to to spit out the answer very quickly, unless you're on some sort of a reality show. But you will need, in your real life situations, to be able to use equations in a context to be able to solve problems in your life. So a lot of the questions on the TASC test do use a context that is realistic, that you might encounter in everyday life, and we feel that's important.
That was well said. I guess I would add one thing here in the end is that just teaching general test-taking skills is still really important. Getting your students to, we already talked about close reading, look at the alternatives, eliminate alternatives, or use the alternatives to guess and check with the answers. Also, a lot of this content may be something that the students looks very intimidating at first. But the question may not be as high level as what the STEM would first lead you to think. So you may not understand parabolas or quadratic equations, but the question may ask you about a minimum. And if you just understand that the minimum's the bottom of the graph, then that's all you need to answer it. And there's several questions like that where it could look scary. You may not have to have a complete understanding, and really some of that may turn into extra information that just is, the old-fashioned extraneous information that's just there to distract you and see if you really can interpret the point of the whole thing. So look at the choices. Don't just give up on the questions. Read them carefully. Try and eliminate answers. Just all those old-fashioned test-taking skills are still going to be really important here.
And so with that, we're going to bring our webinar on math on the TASC to a close. I want to thank again everybody for participating. Eric and I commit to having this posted on collectednewyork.org. Everyone who's participating will get an email with a link to it, but we will post the resources that were mentioned, certainly the PowerPoint, and certainly a recording of what you all have been listening to for the last hour and a half. Thank you so much. I can't stop thanking you guys, Deedra and Tim. Thank you to Eric, and everybody be well, and good luck in all things.
Thanks, everybody. I really appreciate you taking the time to learn this with us.
Thank you so much.
If you want to stay on for a minute,